Section 6.1, Classifying Quadrilaterals. Parallelogram. A parallelogram is a quadrilateral with both pairs of opposite sides being parallel. First of all, let's determine what opposite sides are. If I have segment AD, the opposite side is a segment that is not adjacent to it. AD, AB, and DC are adjacent segments. Therefore, the opposite side would be BC. Similarly, if I have segment DC, the opposite side to that segment would be the non-adjacent segment, which would be AB. Knowing that I have parallel segments inside of a quadrilateral, I can determine all types of angle measures determined by the theorems from previous chapters. For example, alternate interior angle theorem, corresponding angle theorem, and same side interior angle theorem. An example would be if I had an angle measure of 35 degrees, I could determine the measure of angle A because A and D are determined by if two parallel lines are cut by a transversal, then same side interior angles are supplementary. Therefore, 180 minus 35 is going to give me a value of 145 degrees. I can continue to find angle B and C in the same fashion. If two parallel lines are cut by a transversal, then same side interior angles are supplementary, and therefore angle C would be 145 degrees. And I can find angle B either by A or C. Again, if I have two parallel lines cut by a transversal, then I have same side interior angles being supplementary. Therefore, angle B is 35 degrees. Also, when we label a parallelogram, we have a symbol in front of my four vertices in the shape of a parallelogram. Then I select a vertice and continue clockwise or counterclockwise to name the vertices. So if I start at B, I then must go to C, D, A, or B, A, D, C. I do not go across the polygon to determine the labeling of my parallelogram. Next, we have special parallelograms. Here, a rhombus. A rhombus is a parallelogram with four congruent sides. Understand that since this is a parallelogram, it has all properties of a parallelogram plus some extra. In this case, it has all four segments being congruent. These segments, DB and CA, are still parallel to each other, and BA and DC are parallel to each other. So I can still use the rules of alternate interior angles, same side interior angles, and corresponding angles to determine angle measure, but now I have all segments being congruent. It is labeled as rhombus DCAB. Again, I can start with any vertice and go clockwise or counterclockwise. I can't go across the rhombus to label the rhombus. Another special parallelogram is a rectangle. A rectangle is a parallelogram. Again, it has all the properties of a parallelogram with four right angles. Again, my opposite sides are parallel. LM is parallel to ON. LO is parallel to MN. But each of my angles measures are 90 degrees. And this is labeled as rectangle LMNO. And again, the same rules apply for labeling my polygon. The last special parallelogram is a square. A square, again, still is a parallelogram, has the properties of a parallelogram with four congruent sides and four right angles. So I have AB being parallel to DC, but those segments are also congruent. AD parallel to BC are parallel, but these segments are also congruent to the other two segments. And all four angles are congruent. It contains all the properties of a rectangle and a rhombus. A rhombus has four sides congruent. A rectangle has four right angles. And again, it has all the properties of a parallelogram. And it is labeled as a square ABCD. Again, has all the rules for labeling my polygon. Now we're going to get into special quadrilaterals. Here we have a kite. A kite is a quadrilateral with two pairs of adjacent sides congruent, and no opposite sides are congruent or parallel. If opposite sides were parallel, then it would be a parallelogram. Kites are not parallelograms. You do not have the properties of parallelograms. But In our kite, and we can see how it's labeled the same way we've labeled all of our polygons, we start with vertices P, P, Q, R, S. We have the adjacent sides being congruent. PS is congruent to PQ, and QR is congruent to SR. But a kite does not have properties of a parallelogram, therefore it does not have the properties of a rhombus, a square, or a rectangle. This set of special quadrilaterals is known as a trapezoid, and in this case an isosceles trapezoid. A trapezoid is a quadrilateral with exactly one pair of parallel sides. Here I have parallel sides AD and BC. The parallel sides in a trapezoid are known as the bases. I have a top base, in this case, and a bottom base. But the bases can be oriented in any direction depending on the rotation of the figure. The bases are just going to be the parallel sides. The non-parallel sides are known as the legs. And a trapezoid is labeled as trapezoid A, B, C, D. Just as we had any other polygon, I start with a vertice and go clockwise or counterclockwise. Again, since I only have one pair of parallel sides, I have to be careful how I use my theorems of alternate interior angles, same side interior angles, and corresponding angles. In this case, if I have a relationship with A and B, that is possible because the two parallel lines are intersected by this transversal. Therefore, A and B are same side interior angles and supplementary. That is similar to D and C. But A and D and B and C have no relationship in that manner. An isosceles trapezoid has a few more properties than a regular trapezoid. Again, we have one pair of parallel sides, and those are the bases no matter how this figure is oriented. But what gives this an extra property is that the legs are congruent. And we will discuss how that affects the properties of an isosceles trapezoid later in the chapter. On this slide, they want us to find the value of each variable. But let's first use the information in the diagram to classify the quadrilateral. In this diagram, I have one pair of opposite sides being parallel. Therefore, this must be a trapezoid. With that information, I know I have one pair of opposite sides parallel, and that means this can be cut by a transversal, and when that occurs, same side interior angles are supplementary. Therefore, 105 from 180 will give me the value of x to be 75 degrees. But I cannot use that same information to find the value of the other two angles, since these two segments are not parallel. On the next quadrilateral, I have four sides that are congruent, and I know that opposite sides are parallel. Then, that would classify this as a parallelogram with four congruent sides. Therefore, this would be a rhombus. As before, I have opposite sides being parallel. And if two parallel sides are cut by a transversal, then I know that same side interior angles are supplementary. Therefore, 36 from 180 would give me 144 degrees. Since these two sides are parallel, I have those two parallel sides cut by a transversal, which would make these two angles, x and y, supplementary. They're same side interior angles. Therefore, 144 from 180 would give me 36 degrees. On this quadrilateral, I do not have any opposite sides being parallel. Therefore, this is not a parallelogram. But what I do have are two pair of adjacent sides being congruent. These two segments are adjacent and congruent. These two segments are adjacent and congruent. Therefore, I would classify this as a kite, and it has no properties of a parallelogram. What I can do is set up an equation for x plus 8 equals y minus 10, but an easier way to do that might be to actually solve for x in my first set of equations for the top two congruent sides. Then I can find x, substitute into the bottom set, and then solve for y. So here, since these two segments are congruent, I have 2x plus 5 equals 17. Subtract 5 on both sides gives me 2x equal to 12, and x is equal to 6. When I substitute into this bottom expression, I get this segment length to equal 6 plus 8, which is 14. Now I can determine y. Since these two segments are congruent, I have an equation, y minus 10 equals 14. Add 10 to both sides, I get y equal to 24. On this slide, they want us to find the lengths of the sides and the measure of the angles. We're given an isosceles trapezoid. With that information, we are given also in the diagram that angle D is congruent to angle C. Angle A is congruent to angle B. The bases are DC and AB. I know that because those are the opposite sides being parallel. Since A is congruent to B, I know that angle B must also have the value of k degrees. Now, DC is parallel to AB, and if two parallel sides are cut by a transversal, then same side interior angles are supplementary. Therefore, k and 4k minus 5 are supplementary. So I can add those together. And I can set that equal to 180 degrees. Then I can solve that equation and get the value of k. K plus 4k is 5k minus 5 equals 180. Add 5 to both sides, I'll get 5k equal to 185. Divide by 5, I get k equal to 17. But recall, the problem asks us to find the measure of the angles. Therefore, angle B is 17 degrees. Angle A is 17 degrees. And since these two angles are supplementary, all I need to do is subtract 17 from 180, and I'm going to get a value of 163 degrees for D and C. Now I have segment lengths that I need to solve for. I cannot use 2a and 4a minus 6 in any way to get a value for a, since I don't know anything about their congruency. But what I can do is use the information about an isosceles trapezoid. I know that the legs in an isosceles trapezoid are congruent. Therefore, I can set 2a minus 5 equal to 15. Add 5 to both sides, I get 2a equal to 20, and a is equal to 10. Now what I can do is use a and substitute in for the bases. For the legs, I know that this is 15, so this leg is also 15. But I needed to find the value of a to determine the length of DC and AB. Since a is 10, 2 times a makes DC have a measure of 20. And a being 10 for AB gives me 4 times 10 is 40. 40 minus 6 is 34 for the measure of AB. Again, we want to find the measure of the segments. And here we're given rhombus DEFG. Recall, a rhombus is a parallelogram, but it has an extra property that all 4 segments are congruent. So I can set up equations being x plus 10 equals 2y minus 4 and 2x equals y plus 8. But notice each equation has 2 variables. Therefore, I'm going to have a system of equations. And I have to choose how to solve that system. I'm going to choose the substitution method. In other words, I'm going to select x plus 10 equal to 2y minus 4. I'm going to solve this equation for x. X equals 2y. Subtract 10 on both sides, I get a minus 14. Now I'm going to set up my other equation using the other segments being congruent. Therefore, 2x equals y plus 8. Since I know the expression for x is 2y minus 14, I can substitute that into this variable. So 2 times, and x is 2y minus 14 equals y plus 8. Now I can solve for y and substitute back in to solve for x. Distributive property for y minus 28 equals y plus 8. Subtract y on both sides gives me 3y. Add 28 on both sides gives me 3y equal to 36. Divide by 3, y equals 12. Now I can substitute back into this equation the value of y, which is 12. So x equals 2 times 12 minus 14. Therefore, x equals 24 minus 14. So x is 10. When I substitute, I'm going to get 10 times 2, which is going to give me 20. For 12 goes into y. Y plus 8. 12 plus 8 is 20. And therefore, each segment must be 20. But I can check that by saying x is 10, substitute in, 10 plus 10 is 20, y is 12, 2 times y is 24, minus 4, which is still 20. Our last example, we're given parallelogram PQRS. I want to find all angle measures in the diagram. Since this is a parallelogram, I know that opposite sides are parallel. Therefore, I can have this angle, 77, congruent to angle S by the alternate interior angle theorem. If two parallel lines are cut by a transversal, then alternate interior angles are congruent. Therefore, angle S is 77 degrees. Also, I can find the measure of angle Q using 77 degrees. If these two parallel lines are cut by a transversal, then corresponding angles are congruent. Therefore, angle Q is 77 degrees. Angle SRQ and SRT are a linear pair. Therefore, I know they are supplemental. So I can take 77 from 180 and get 103 degrees. I can find angle P from either S or Q using the same method. Let's use Q. If two parallel lines are cut by a transversal, then same side interior angles are supplemental. Therefore, 77 from 180 leaves me 103 degrees for angle P.